This lesson is writing two-column proofs for congruent triangles. So we're going to be given two triangles with various information, and then we're going to prove that those triangles are congruent using any of the 5 reasons. Remember, those 5 reasons are SSS, SAS, ASA, AAS, or HL. So when you're doing a congruent triangle proof, you're given information and you're trying to prove information. Whatever you're given, mark that information in the picture. Then mark any reflexive sides or angles or any vertical angles. Also mark any information implied by the given information, like if you have midpoints or segment bisectors or something like that. And decide which method you're going to use. Will it be SSS, SAS, ASA, or AAS, or HL? Then you'll list the parts in the proof, fill in the reasons. Sometimes it's given, sometimes it's because vertical angles are congruent, or what have you. And then, is there more? Remember, your last statement should be what you're trying to prove. Are you trying to prove triangles congruent? Well, then that's going to be your last statement. Are you trying to prove that parts of triangles are congruent? Well, you have to still prove that the triangles are congruent first, and then take it one step further. So these might seem very strange at first, but the more you do, the more familiar you are with it, and the better you'll be. So let's do this example. We're given this picture, and it says segment AB is congruent to segment CD. Segment BC is congruent to segment DA. Prove the triangles are congruent. Well, let's mark the given. Segment AB is congruent to segment CD, and segment BC is congruent to segment DA. And now I can also see that they share a side, so I can mark that as well, the reflexive side that they share. And I can predict that I'll say these triangles are congruent because of side, side, side. Now let's write the proof. You should always start with what you're given. And we're given that segment AB is congruent to segment CD, and segment BC is congruent to segment DA. And the reason we know that's true is because they told us. We were given that information. That's 2 pairs of sides, which is not enough to say the triangles are congruent. Well, say the next piece, the side that they share. Segment AC is congruent to segment AC, and the reason that's true is because anything is congruent to itself. That's the reflexive property. I have now identified all 3 pairs of sides that are congruent, and that's enough to say that the triangles are congruent. So now I can go ahead and say the statement I'm trying to prove. Triangle ABC is congruent to triangle CDA, and I know that's true because of the SSS postulate. Start with what you're given, add any additional information, the vertical angles, the shared sides, the angle bisectors, or whatever, and then once you can say the triangles are congruent, say that, give the reason why. Here's another one. Given that segment AB is congruent to segment CB, and segment EB is congruent to segment DB, prove that the triangles are congruent. Well, in the proof, go ahead and write out what you're given first. Segment AB is congruent to segment CB, and segment EB is congruent to segment DB. And the reason we know that's true is because we were given that information. Now that's two pairs of sides, which is not enough to say the triangles are congruent. So what other information can we say here? They don't share any sides, but I do see some vertical angles here in the middle, so let's use those. Vertical angles are always congruent, so I can use that. Angle ABE is congruent to angle CBD. Those are vertical angles, so the reason will be because vertical angles are congruent. You can abbreviate if you want, as long as it makes sense. Now I can see in the picture, I have side, angle, side on the left, side, angle, side on the right. So these triangles are congruent. I can say that they're congruent now. Write it exactly the way it says in the proof statement. Triangle ABE is congruent to triangle CBD. Why? Because of side, angle, side. So write what you're given. Identify any additional information, the shared sides, the vertical angles, the segment bisectors. Once you have enough parts to say that the triangles are congruent, then say that they're congruent and give the reason. Here's another one. We're given this picture, and we're given that angle XWY is congruent to angle ZWY. Well, there's angle XWY and angle ZWY. We're also given that angle XYW is congruent to angle ZYW. Prove that the triangles are congruent. Well, right now I have two pairs of angles, and there is no AA postulate, so I need more information. Are there any vertical angles? No. Any shared sides? Yes, they share that side in the middle, so I can see right away that I'm going to be using that shared side. So let's go ahead and start the proof. Begin with what you're given. Angle XWY is congruent to angle ZWY, and angle XYW is congruent to angle ZYW. And we know that's true because we were given that information. And then we have the shared side in the middle, so we can say that that segment is congruent to itself. Segment WY on the top triangle is congruent to segment WY on the bottom triangle. Anytime a segment is congruent to itself, that's the reflexive property. Now I have it. I have on the top triangle angle, the next side, and the next angle. Angle, side, angle. And then on the bottom triangle, you've got angle, next side, next angle. So we have ASA. So I can say the triangles are congruent now. Triangle WXY is congruent to triangle WZY because of angle, side, angle. Write what you're given. Is there any other information? Here we had a shared side, which is true because of the reflexive property. And then I have angle, side, angle. Two angles and the included side. Remember that every proof starts with what you're given, and the final statement is always going to be whatever it is you're trying to prove. So you're not done until you can say what you're trying to prove. And once you've said that, then the proof is complete. Here's another one. We're given that triangle ABC and triangle ADC are right triangles, and we're given that segment AB is congruent to segment AD. Prove the triangles are congruent. Well, let's mark the picture. If these are right triangles, it's very obvious that the right angles will occur at vertex C. And then segment AB is congruent to segment AD. Since these are right triangles, I'm going to want to have HL at the front of my mind. Because anytime you have right triangles, you can always prove that those are congruent because of hypotenuse leg. Well, I already have the hypotenuses. And then, is there a pair of congruent legs? Well, they share that side right there. And that side is a leg on both triangles. So I can already see where this proof is going. So, as always, let's start with what we're given. First statement is what we're given. Triangle ABC and triangle ADC are right triangles, and segment AB is congruent to segment AD. And we know that's true because we were given that information. That gives us that they're right triangles, and that gives us a hypotenuse. Well, let's go ahead and mark the leg. Since we have the side AC on both triangles, it is congruent to itself. And it's congruent to itself because of the reflexive property. Now I have the hypotenuse and I have the leg, so I can say the triangles are congruent now. Triangle ABC is congruent to triangle ADC because of hypotenuse leg. We started with what we're given. They're right triangles, and we have a pair of hypotenuses that are congruent. Add the additional information. Leg AC is on both triangles, so it's congruent to itself because of reflexive. Now I have HL. Triangles are congruent because of HL. Sometimes there's additional pieces of information that let you know that triangles are congruent, and you have to use those as well. Sometimes you're given a midpoint, and if you have a midpoint, you're going to be having the two half segments congruent, so you'll use that. Sometimes you'll be given that sides are parallel, and if sides are parallel, you can count on having congruent angle pairs. Most of the time it'll be alternate interior angles. Sometimes you have a segment bisector, and if a segment's cut in half, you know that the half segments are congruent. Sometimes you have an angle bisector, and if that's the case, the two angle halves are congruent. And sometimes you have a perpendicular, and since perpendiculars form lots of right angles, you can use that those right angles are congruent. So that's other types of information that give you congruent parts of triangles, in addition to the shared sides that are reflexive and the vertical angles, or the shared congruent angles that are reflexive. All of these are just additional pieces until we can get SSS or SAS or any of the others. Once we have enough pieces of information to say the triangles are congruent, then we'll say that. So here's another one. We are given that segment AC bisects angle BAD, and segment AB is congruent to segment AD. Prove the triangles are congruent. Well, I have an angle bisector. Angle BAD is bisecting that angle up at A. And I know that segment AB is congruent to segment AD. So let's go ahead and start the proof. Start with what you're given. And the reason is given. Then add the additional pieces. Since I have an angle bisector, I know that those angle halves are congruent. So I can say angle BAC is congruent to angle CAD. Why are they congruent? Well, that's what an angle bisector does. That's the definition of an angle bisector. Anytime you have an angle bisector, make the angle halves congruent, and the reason is the definition of an angle bisector. Well, that's a pair of sides and a pair of angles. That's not enough information. What else do you have? We have the shared side in the middle, so let's use that too. Segment AC is congruent to itself. Segment AC is on the left triangle and it's on the right triangle. When something is congruent to itself, that's always the reflexive property. Now I've got a pair of sides, a pair of angles, a pair of sides. This is two sides with the included angle. I have side, angle, side. So the triangles are now congruent. Triangle ABC is congruent to triangle ADC because of side, angle, side. Now once the triangles are congruent, even though we're not worried about it yet, we can also say that all of the remaining parts are congruent. So segment BC is congruent to segment CD. Angle B is congruent to angle D, and angle ACB is congruent to angle ACD. So I know that all those other corresponding parts are also congruent. I didn't need that here, but I can understand that that is true once the triangles are congruent. Here's another one. You're given that C is the midpoint of segment BD and segment AB is congruent to segment AD. Prove that the triangles are congruent. Well, if there's a midpoint, then you have the half segments congruent. So I know right off that that segment BD is cut in half and those two halves are congruent. I also am given that segment AB is congruent to segment AD. So let's go ahead and start the proof here. Statement 1, C is the midpoint of segment BD, and segment AB is congruent to segment AD. And as always, that's given. Then, remember, we have a midpoint, so the two half segments are congruent. I marked them in the picture, but you also have to write that in the proof. Segment BC is congruent to segment CD. It's because of the midpoint. And if you have a midpoint, then the two segment halves are congruent, and that is the midpoint theorem. The midpoint theorem says that the midpoint of a segment cuts a segment into two congruent halves. Well, that's two pairs of sides. SS isn't enough. They didn't tell us anything else, so I have to decide from the picture what else I have. And what I have is a pair of congruent sides here in the middle, the side that they share. So segment AC is congruent to itself. And we've seen this quite a few times so far. Hopefully you remember. That is the reflexive property. Now I've got all three pairs of sides, so I have SSS. The triangles are now congruent. Use what you're given, mark anything else that you can imply, and then say that the triangles are congruent. Here's another one. Given that segment AB is parallel to segment DC, and segment AD is parallel to segment BC, prove the triangles are congruent. So I can mark the parallel triangles there to show that those are parallel. Now they didn't tell us any pieces are congruent, so I'm going to have to do a lot of thinking here. Well, let's start with what we're given though. Segment AB is parallel to segment DC, and segment AD is parallel to segment BC, because we're given that. Now the thing to remember here is that when lines are parallel, you have congruent angle pairs. If AD and DC are parallel, cut by that transversal, you have alternate interior angles that are congruent. Also, when these parallel lines are cut by a transversal, I can do that better, cut by that transversal, another pair of alternate interior angles is congruent. So when you have parallel sides, look for alternate interior angles. There's one pair, there's the other pair. So let's use that information in the proof. Angle BAC is congruent to angle ACD, and angle DAC is congruent to angle ACB, because alternate interior angles are congruent when lines are parallel. Well, that's two pairs of congruent angles. Still not enough information to say the triangles are congruent, so what else do we have? You've got the shared side. Anytime there's a shared side, it's congruent to itself because of the reflexive property. Now I have two angles and the included side on each triangle, so the triangles are congruent. Triangle ABC is congruent to triangle CDA because of angle side angle. Now again, here we had parallel lines cut by a transversal, alternate interior angles there. Parallel lines cut by that transversal, alternate interior angles there. So use those when the lines are parallel. Here we're given some segment bisectors. Segment bisectors implies congruent segments. We're given a couple of segment bisectors. Prove the triangles are congruent. So let's start with what we're given. Segment AD bisects segment EC, and segment EC bisects segment AD. Why? Because they gave that to us. Now they didn't say anything is congruent yet. We have to imply that. If segment AD bisects segment EC, then segment EC is cut in half. So those two parts are congruent. And if segment EC bisects segment AD, then segment AD is cut in half. So those two parts are congruent. That's what I'll use in the proof. Segment EB is congruent to segment BC, and segment AB is congruent to segment BD. Why? Well, because the segment was bisected. That's the definition of a segment bisector. That's what a segment bisector does. Well, that's two pairs of congruent sides. SS is not enough. So what else do we have? We've got vertical angles. So use the vertical angles. Those are always congruent. Angle ABE is congruent to angle CBD because vertical angles are congruent. And now I have two sides and the included angle on each triangle, so the triangles are congruent. Triangle ABE is congruent to triangle DBC. Why? Because of side angle side. You have a side, the next angle, and the next side. A side, the next angle, and the next side. In this proof, we're given that segment AC is perpendicular to segment BD, and that segment BC is congruent to segment DC. So we've got perpendiculars forming right angles there, congruent segments there. Prove the triangles are congruent. Well, let's write what we're given here. Segment AC is perpendicular to segment BD, and segment BC is congruent to segment DC. And we know that's true because we were given that. Now, since the perpendiculars form right angles, I have right triangles, so I'm probably going to be using HL. So let's go ahead and build this. Since they're perpendicular, then we have right angles. So I have to say that angle ACB and angle ACD are right angles. And that's because perpendicular lines form right angles. If I'm thinking ahead here, if I'm going to do hypotenuse leg, I would need to know that the two hypotenuses are congruent. But I don't see anything that implies that. What I do see instead is this shared side. Well, that's another leg. So I'm not going to be doing HL here. So let's think of this differently. Instead of saying that they're right triangles, I know they're both right angles. So let's say instead that those right angles are congruent. Angle ACB is congruent to angle ACD because right angles are congruent. Now we originally were thinking there, hey, I've got right angles, I might be doing HL. But as we went along there, I don't have any way to say that the hypotenuses are congruent. So we took a little different route there. So that gives me a pair of congruent angles there. I also have that shared side that I marked a minute ago. Segment AC is congruent to segment AC. When something is congruent to itself, that's always reflexive. And now, instead of HL, what I have is side angle side, which matches side angle side. So let's say the triangles are congruent because we have two sides and the included angle. Sometimes you might start a proof thinking one way and then realize you have to take a slightly different route, and that's okay. Just use what you're given, use what you're able to imply, and build the proof that way. Now, so far, we've taken all of our proofs and we've said, we've given all the information and written it down, and then finished by saying that the triangles are congruent. But sometimes they want to go one step further and not just say that the triangles are congruent, but an additional pair of parts is congruent. And you do that by using CPCTC. That stands for corresponding parts of congruent triangles are congruent. So if two triangles are congruent, then their corresponding parts, the side pairs and the angle pairs, are also congruent. So any two sides or angles that are not marked as congruent can be proven congruent if they're part of two congruent triangles. So when we prove the congruence this way, we'll abbreviate it CPCTC. We will say the triangles are congruent and then go one step further and say that the parts are congruent. The reason is CPCTC. So here's another proof. We're given angle A is congruent to angle B, and segment AM is congruent to segment MB. Prove segment AD is congruent to segment BC. They're not saying prove the triangles are congruent, but we do have to prove the triangles are congruent and then go one step beyond. So let's start with what we're given. Angle A is congruent to angle B, and segment AM is congruent to segment BM. Segment MB is the way they write it. And that is given. That's a pair of sides and a pair of angles. That's not enough to say the triangles are congruent, but I do have vertical angles. So I can say that those are marked angle 1 and angle 2. So I can say that angle 1 is congruent to angle 2 because vertical angles are congruent. Now I have angle, side, angle in each triangle. So I can say that the triangles are congruent. The bottom triangle is triangle AMD, and in the top triangle, A matches B, M matches M, D matches C. Those are congruent because angle, side, angle. I have ASA. Now normally we would stop there, but we have to go one step further. We're proving the segment's congruent. Once triangles are congruent, any of their corresponding parts are congruent. So segment AD is congruent to segment BC. So let's add that to the end. And the reason is because corresponding parts of congruent triangles are congruent, CPCTC. So if they want parts congruent, say that the triangles are congruent first, then say the parts are congruent because of CPCTC. Here's our last proof. They give us that segment FO is congruent to segment FR, and segment OU is congruent to segment OR. Prove that angle R is congruent to angle O. So let's start with what we're given. Segment FO is congruent to segment FR, and segment OU is congruent to segment OR. And as always, we know that's true because they gave it to us. And notice they're proving parts congruent, not triangles. So we still have to show the triangles are congruent first, Then take it one step further. Now I've got two pairs of sides. SS is not enough. What else do you know? Well, they share a side in the middle, so let's use that. Segment FU is congruent to segment FU, and that is because of the reflexive property. Now I have a third pair of sides. We have SSS. So the triangles are congruent. The left-hand triangle is triangle OUF, and the right-hand triangle, let's see, O matches R, U matches U, F matches F, and I have SSS. That's why those triangles are congruent. And then go that one step further. I know that angle R and angle U have to be congruent. Since the triangles are congruent, any of their corresponding parts are congruent because of corresponding parts of congruent triangles are congruent. CPCTC. So start the proof with what you're given. Then do any of the information you can imply. The shared sides, the vertical angles, the midpoints that cut a segment in half, the angle bisector that cuts an angle in half, any of those pieces. Get enough information to say the triangles are congruent, and if you have to go one step further, say the parts are congruent because of CPCTC.